Hello, and welcome to this session, What's New with AWS Lake Formation. I'm Sanjay Srivastav, Product Manager for Lake Formation. I'm excited to show you how to manage data lake security using AWS Lake Formation, row level, and tag-based access controls. But before we get started, let's talk about some of the challenges you, our customers, are having with your valuable data. Data volumes are increasing at an unprecedented rate. They're exploding from terabytes to petabytes, and sometimes even to exabytes. Traditional on-premise data analytics approaches can't handle these data volumes because they just don't scale and oftentimes are too expensive. We hear from companies all the time that they're looking to extract more value from the data, but struggle to capture, store, and analyze all the data generated by today's modern and digital businesses. Data is growing exponentially, but it's also coming from many sources, is increasingly diverse, and needs to be securely accessed and analyzed by a large number of applications. Against this backdrop of increasing data, there is a desire to get the right data to the right people. And this is where data lakes come in. Lake Formation is a service that helps you build a secure data lake in days instead of months. With Lake Formation, you can move, store, catalog, and clean your data faster. You simply point Lake Formation at your data sources. Lake Formation then crawls these sources and registers the data with your Amazon S3 data lake and makes it available to the analytics and machine learning tools. AWS Lake Formation simplifies security management. It provides a secure access layer on top of your sensitive data. Your users can control a centralized data catalog, which describes available data sets and their appropriate usage. And then leverage these data sets with their choice of analytic tools. Lake Formation provides fine-grained access controls to share data between consumers as well as across accounts. Lake Formation makes it easy to centrally define and enforce security and governance policies. It supports database, table, column, and now row-level security policies. Lastly, it provides you the ability to easily discover data by cataloging all your assets in one single place. And once you have that single central point, you're then able to control and view and analyze how that data is being accessed and track its lineage. Lake Formation is at the center of the AWS Analytics Lakehouse architecture. It helps share data securely across purpose-built databases and warehouses. Let's now look at the AWS Lake Formation solution stack. It starts with a data lake storage on Amazon S3, a cost-effective, durable storage with global replication capabilities. It provides blueprints along with a tight integration with Glue to ingest data easily, ML transforms to clean the data, to help data engineers build data lake faster. It provides a centralized catalog for your data lake resources, centralizes management of fine-grained access controls, and auditing capability to help security officers enforce governance. And all of this, and it makes the data available to a wide variety of integrated tools that help democratize data access and provide you choice in terms of analytics tools so that you can use the right tool for the right workload. As part of the agenda today, I'm first going to recap some of the core features of Lake Formation, the database, table, column level security, and cross-account support. I will then introduce new features that show you how you can enforce row and cell level security, scale permissions with Lake Formation tag-based access control, and also manage real-time data lakes with governed tables. So let's get started with a recap. Lake Formation discovers and catalogs all your data on S3 storage. It provides database, table, column abstraction on top of your data and allows you to grant permissions on those catalog resources. You can then easily share entire databases, multiple tables, columns and rows with principals. And these principals can be either IAM principals or SAML identities. It integrates with a wide variety of services to enforce fine-grained permissions. Both AWS services such as Amazon Athena, AWS Glue, Redshift, QuickSight, AIML tools like SageMaker, and in the near future with third-party tools as well. Free is a market leader in providing cloud-based accounting and HR software based out of Japan. Free uses Lake Formation to minimize the number of IAM policy updates required to share and secure their data lake. Let's turn our attention to cross-account sharing. Cross-account sharing in Lake Formation builds on in-account sharing by extending it to other accounts. Just as grants can share access to databases, tables, or specific columns with users, you can also do the same with multiple accounts. And you can share databases, tables, or specific columns with other accounts. Lake Formation works with a central authority, in this case RAM, to share these resources from producer accounts to consuming accounts. Let's walk through a quick example. What I'm showing you on the screen right now is a producer account, EU account with a data catalog. In the data catalog, they have a sales database and an opportunities table. Once they grant a cross-account grant to another account, it then gets shared with the consuming account through RAM. This resource is then available in the consuming account to the admin. Think of this as a pointer, a symbolic link pointer in Unix. Now, this pointer can then be named by the admin by creating a resource link and making it available within the local account. Once the resource link is created, the admin can then define permissions on the resource link and provide permissions on the shared resources. Once permissions are created, these resources can then be accessed from any of the supported tools, Amazon Athena, Glue, EMR, or Redshift, and become available to users just as if they were available in the local account. Using cross-account, our customers have set up many different topologies. The benefit of cross-account is that you can share these data without actually copying or moving data. Lake Formation has been used by our customers to implement many different topologies, whether it be a centralized hub and spoke model or producer-consumer accounts, such as across orgs, within orgs, or even across companies. Using scenarios like supplier or vendor or aggregator or distributor. It is being used to set up data mesh architectures in a many-to-many setup as well. GoDaddy is a user of AWS Lake Formation cross-account. GoDaddy is an American publicly traded internet domain registrar and web hosting company with more than 20 million customers worldwide. GoDaddy uses Lake Formation in a hub and spoke architecture. With Lake Formation, producers publish their shareable data to a centralized hub, and consumers can access data from that hub using Lake Formation cross-account. D2C is a digital advertising and marketing firm from Japan. They use Lake Formation to share data across accounts while ensuring that certain PII columns are restricted as part of the share. Let's switch gears now and talk about some of the new features, starting with row-level security. Why do you need row-level security? Oftentimes, you have a large fact table that is shared across groups and departments, or a single table that is being populated by multiple services. In these cases, you want to make sure that users have access to only specific rows. For example, for patient records, you want the admins to see all the records, but the doctors and nurses should only be able to see their own patients' records. Similarly, in a retail scenario, you want the retail orders to be available to the store manager just for the single store that they manage. But regional managers should be able to see all stores' records within their region. Today, to solve this problem, requires multiple redacted copies of the same data, resulting in escalating costs related to write amplification and complexity and lack of visibility, because your permissions now get distributed over a large number of objects and are no longer centralized. AWS Lake Formation row-level security enforces permissions through a set of read APIs that enforce granular compliance policies and filter out data in a consistent manner. Row-level security permissions are expressed as the where clause in particle. For instance, country equal to US. Row-level security supports many S3-based table formats, whether it be open formats such as CSV, Parquet, etc., or managed formats such as governed tables, Redshift data shares, or in the near future, formats such as Apache Iceberg, Hudi, and Delta Lake. And it does this with consistent enforcement and audit of permissions and access. Cell-level security builds on row-level security by extending it to control column access based on row-level predicates. For instance, show all columns where country equal to US, but share all columns except for PII when country equal to UK as a possible grant. Cell-level security also creates named cell regions that allow you to reuse security constructs in a scalable manner. For instance, creating a data filter such as PII data in the US, which can then be reused across multiple principals. Next, let's take a quick demo. Let's do a quick demo to see this particular scenario. In this demo, we have a sales database with a customer table that is being shared across teams. As per governance policies, the US analyst can only see US rows. The Canada analyst should only see rows where country equal to Canada. There are 3 steps to implementing cell-level security. The first thing we're going to do in the demo you're about to watch is to create a data filter. Next, we'll grant permissions based on the data filters. We will then validate the permissions using Athena as a query engine. So let's get started with the demo. But before we create a data filter, let's go ahead and explore the data. To do that, I'm logged in as a manager. And here, as the manager, I can see the sales database and the customer table. The data itself consists of records both from US and Canada, as represented by the column country. It also has many columns, including some which could be PII. Note, all data that's being used in this demo is fictional. It's not real. So this is fake data. But in this case, the last name column, the date of birth column, the phone number, the building number, the street number could potentially be the street name could all be PII data. The view that you're seeing right now is the view of the manager. Let's go ahead and create a data filter to restrict the view. To do that, I'm going to go back as the manager and create a brand new data filter. By clicking on Create New Filter, I'm going to give it a name, US only. Select the database, in this case, the sales database, the table customer, and I'm going to give access to all columns, along with a row level predicate, country equal to US. Before I click on Create Filter, I just wanted to also walk you through some of the other options available here. To create a cell level filter, you can choose a set of columns to include as part of the filter. In this case, if you wanted to choose a specific set of columns and tie that to the predicate, you can do so by choosing columns here. You can also exclude, for instance, all of the PII columns by selecting the PII columns and making it part of the filter. Now, this would be an example of a cell level filter. In this present example, I'm interested in a simple row level filter for US only data. So by clicking on Create Filter here, I have a simple row level filter. Now that the row level filter is created, US only, I can next grant permissions based on that filter. To do that, I click on Data Permissions, click on Grant, choose the IAM principal that has access to this data. In this case, I'm trying to give the US analyst access to just the US data. So I'm going to go ahead and click on the US analyst, choose Name Data Catalog Resources, select my database, sales, my table customer, select the permissions, in this case, select and describe, and limit or restrict the set of columns to US only by selecting the data filter. Once I do the grant, this US analyst can see just the US rows. But before I click on grant, I just want to show you what the view looks like for the US analyst by running the query prior to the grant. As you can see, the US analyst has access to none of the columns in that database. Let's go ahead and create the grant, complete the grant here. And let's go ahead and validate the access by running the query. While the query is running, let me also show you what the access is for the Canadian analyst. The Canadian analyst uses a similar filter as the one we just created for US with country equal to Canada. As you can see, the Canadian analyst only gets access to the Canada data. And this is the analyst from Canada. Let's take a look at the US data. And we can see here that the US analyst now has access to just the rows where country is equal to US. Before we drop off, I just want to show you one last quick example of a cell level filter. I have a complex cell level filter here called CA non-PI only. Let's take a look at what that looks like. It restricts access to for all rows where country equal to Canada by excluding phone, date of birth, building number, and street name. Let's actually take a look at what the result looks like for a user that has this filter. I previously ran this earlier today, and you can see this user campaign manager has access to just the data in Canada with those columns, date of birth, phone number, building number, and street name hidden from that person's view. So with that concludes the demo. Let's go ahead and recap what we saw in the demo. In the demo, we started off by creating a data filter. I showed you how to create both a simple row level filter as well as a more complex cell level filter. We then did a grant based on that data filter and to a specific set of users, in this case, the Canadian analysts and the US analysts. We were then able to go and validate the access from Athena for those users once the permissions were in place. And we ensured that the Canadian analysts only saw Canada data and the US analysts only saw the US data. Next, let's switch gears and talk about lake formation tag-based access controls. So why tag-based access controls? Lake formation customers are managing larger and larger number of databases, tables, and thousands of columns all the time. As the number of these resources increases, it becomes more and more difficult to scale permissions. If you have M resources and N principals, you end up with M times N grants. And that can be very difficult to manage. This tight coupling between resources and grants also means that grants can only be created once the resource has already been created. Further, this also means that for every resource add, you need to then go back and do a permission update, which leads to policy explosion, but also policy update issues. This makes the entire process extremely cumbersome and difficult. But with tag-based access control, you now can scale your permissions management easily. It allows data stewards to define a set of tags as part of an ontology for governance and controls who can see or attach these tags. It allows developers and data lake admins to independently tag and grant permissions. Permissions are then evaluated at runtime, thus simplifying the entire workflow. In the example shown on the screen here, we've got two tables, one a sales table and another a marketing table that are tagged appropriately, and a set of columns that are tagged with a tag PI equal to true. As you can see, the sales manager gets access to all resources where department equal to sales and PI is false. The executive gets access to all PI data. And finally, the marketing executive gets access to all resources where department equal to marketing and PI is equal to true. Now let's see this in action. We're going to go back to the same data set we previously looked at with a table customer in a sales database containing some PI data. This time, we will use tag-based access controls to create a policy that restricts access to PI data. There are going to be 3 steps involved. The first is to create a tag ontology with PII as a tag and with values true and false. Next, we're going to go ahead and tag the database with PI equal to false. We will then tag specific set of columns with PI equal to true. Finally, we'll create policies and do grants based on the tag. And then query the data from Athena to see the results of the grants. Let's get started. I'm going to go back to the same table. Just as a reminder, this table has many columns that are potentially PII, including last name, as well as date of birth, phone number, building, and street name. This is the view that the admin sees. Let's go ahead and create a tag-based grant. To get started, I'm going to go into policy tags and create a brand new tag within the ontology by clicking on add tag. I'm going to name this tag PII. And I'm going to provide 2 values, false and true as possible values for tag PII. And go ahead and add that to the ontology. Once it is part of the ontology, the next step is to grant permissions to a specific set of individuals. In this case, as an admin, I have access to those tags, but if I so wanted, I could then grant permissions to specific individuals. So for instance, the developer to this tag, as well as possible values that the developer can use, along with the ability to see the tag, as well as the ability to associate the tag. Now, after this grant, the developer is also able to tag resources and attach this tag to resources that he creates. Next, I'm going to go ahead and tag the database. In this case, the sales database. I'm going to go ahead and add tags at the database level and define this as PI equal to false. So basically what I'm saying is this database contains data with where PI equal to false. Based on the hierarchical nature of tags, all resources within the database now have PI equal to false tags. Next, let's find the customer table and tag it appropriately. In this case, the table name is customer. I'm going to go ahead and find the table customer in the sales database, and I'm going to tag the columns appropriately. To do that, I click on Edit Schema, choose a set of columns. In this case, I'm going to choose the last name, the date of birth, the phone number, the building number, and the street name, and I am going to tag them with PII equal to true. As you notice, it already has a tag of PII equal to false, which is inherited from the database. Here, I'm overriding that with a value of true. Once I do that, now all of the resources within the database sales are tagged PII false, except for this set of columns, which are tagged PII equal to true. And now we're ready to do grants based on these tags. Let's go ahead and create permissions based on the tags. To do that, I click on Data Permissions, click on Grant, choose a set of principals. In this case, I'm trying to limit access for the business analyst, who I can choose here. Next, I'm going to choose a set of policy tags to limit access on. Here, I will choose PI equal to false as a set of resources that this user has access to. I'll also choose a set of permissions. From a database perspective, I will give access to describe permissions to this user. And from a table perspective, I'll allow them to select and to describe data within this table. Clicking on grant completes the task of granting based on that tag PII equal to false. Now, lastly, I'm going to go ahead and query this data from, as the user, in this case, the business analyst, using Athena. Clicking on Run Query shows you the data that this user has access to. As you can see, the columns containing PII data, such as last name, date of birth, street name, building number, are no longer available to this user. That concludes the demo. In this demo, I showed you how to create a tag ontology. I showed you how to create grant permissions on the tags. I then went ahead and did a grant based on the tag. And finally, I validated the permissions by using Athena as the query engine. Let's switch gears now and talk about governed tables. With Lake Formation, you're able to manage permissions across databases, tables, columns, and rows. But there are still a few challenges in managing your data. The first challenge is continuous updates. As data is continuously getting updated, it's difficult to handle. It requires complex ETL to provide a consistent view to end users. These complex ETLs often result in delays in data freshness and are often expensive and brittle and error-prone to maintain. The next challenge is that the performance is inconsistent. There is overhead with managing the updates, overscanning of data, small file performance issues related to small files, as well as managing partition updates. Lastly, complying with regulations is often not easy, especially when you have multiple copies of data to manage and to manage permissions on. To address these issues, we recently introduced governed tables. Governed tables are a new type of S3 table that support ACID transactions. Users can perform multiple operations across multiple tables initiated by many users from various engines, all within the bounds of a transaction. This allows the tables to be updated in an atomic manner, with query users being isolated to changes as part of the query, and they can complete their run. This ensures they have a consistent view of the data. With governed tables, there is no lock-in because the data is stored right into your S3 buckets in open table formats, such as Parquet, CSV, etc. The metadata itself can be exported at any time to other formats, such as Delta, Hoodie, or Iceberg. Governed tables support time travel semantics so that you can now travel back in time and run query at an earlier point of time. Huddle is a leading performance analysis company that provides analytics to coaches and athletes to stay ahead of their competition. With transactional ETL, Huddle is able to reduce development time and reduce complexity by simplifying ETL and the effort needed to produce trustworthy data. To access governed tables in preview, we also introduced a set of update and access APIs to the data lakes that provide access and accelerate access to the data lake, support row-level security, and have open and public APIs that you can build your own applications on. Governed tables in preview are integrated with Athena and Glue during the preview, and Redshift and EMR will follow soon at GA. To summarize, as part of this presentation today, we looked at core Lake Formation functionality, such as table, column, and database level permissions, fine-grained permissions, as well as cross-account sharing. And also looked at the new features, row-level security, which extends fine-grained permissions to specific rows, and cell-level security, which allows access to a set of columns based on row predicates. We also looked at Lake Formation TBAC, which enables logical grants and revokes and allows you to independently create resources and grants independently, thus allowing for scalable governance. Finally, we reviewed governed tables, although briefly. Governed tables, a new S3 table type, allows you to transactionally add, delete, update data in the data lakes while providing consistent view of the data lake to all concurrent queries. Lake Formation TBAC is in GA and is available in the 8 regions shown on the screen on the left. Govern tables and row-level security is in preview, available in Northern Virginia and Oregon. Other regions will follow soon at GA. Here are some resources to get you started. The AWS Analytics Big Data blog is a great resource for lake formation use cases as well as how-tos at the link above. You can find blogs that show you how to use lake formation, TBAC, row-level and cell-level security, and govern tables. Please check out the URL. Here are some sample blogs from the recent past. As a reminder, if you want to get access to govern tables or participate in the preview, please sign up at aws.amazon.com/lake-formation/preview. And once again, thank you for attending this session.